Hello, everyone. Welcome to today's Luohan Webinar. It's Xijie Gao from Luohan Academy. So today we are very happy to have Professor Thomas Philippon from NYU to talk about data sharing and market power with two-sided platforms. So Professor Thomas Philippon is a Max L. Hanning Professor of Finance at New York University Stern School of Business, and he was named as one of the top 25 economists under age 45 by the IMF in the year 2014. So he has won numerous prizes, including Benazer Prize for Best European Economist under age 40, Michael Brennan and BlackRock Award, and Prize for Best Young French Economist, and also the Bradley Prize for the Best Paper in Corporate Finance. And Professor Philippon has studied various topics in macroeconomics and finance, including systemic risk, crisis resolution mechanisms, and dynamics of corporate investment and household debt, and size of the finance industry. So recently, he has been working on the topics related to the Eurozone crisis, financial regulation, and market power for large firms. So without further ado, Professor Philippon, please take it over. You have about 90 minutes. Thanks.
Thank you very much. Thank you very much for inviting me, and thank you for allowing me to change the time, because I was traveling last week and I would not have been able to do it. So this is joint work with Rishabh Kirpalani, who is at Wisconsin-Madison. Just to be clear, you feel free to interrupt anytime you want to ask questions. I don't think I'm going to need 90 minutes for the paper. I think we can plan for an hour, and then we have more time for discussion after if you want. So the paper is about trying to understand the specificity of data sharing in platforms that have two sides. Okay, typically one side is made of merchants and one side is made of consumers. So, I mean, needless to say, like if you look around, you can see that internet platforms have drastically changed the way market participants interact. Okay, but that if it was just that part, I think you would interpret this new platform as the same technology with a higher productivity. Okay, if you purely think of them as a marketplace where buyers and sellers can meet, then what is Amazon in this world? Well, Amazon is just like a supermarket, except that there are many, many more products. So the choice is much wider, which in the language of this model, that means there are many more merchants who are there offering different types of goods. It's much easier to find something, right? Like the search function on Amazon is, orders of magnitude faster and more efficient than just walking the aisles of the supermarket to find what you want. But if it was just that, then you would say, well, it's just like a big market, except it's more efficient. It's just a better matching function. But it's not the whole story. And no, there are many differences you could argue, but the one we're going to focus on is the fact that these internet platforms, at the same time as you can think of them as a large matching function where buyers and sellers can meet, like in any kind of bargaining model, they also deal with data. Okay, that is, they gather data from past transactions, from browsing histories, and they use the data a lot. And it's not by chance. Okay, the fact that they are deeply involved in the business of gathering and analyzing data, it's not fortuitous. It's not something that just happened on the side. It was designed from the beginning. In fact, if you read the history of Amazon, you see that Bezos, from the first website, from the very beginning of Amazon, when it was essentially a bookseller, okay, always had the idea that the key advantage of this internet platform would be, sure, there would be more stuff. It would be easier to find anything you want. Which is why he started with books, by the way, because books are easy to store. Okay, so the storage cost is low. You're just in the big warehouse. The inventory is very large because there are many, many different titles. Okay, so that means that for a physical store, for a library, for a bookstore, it's very hard to have everything available, right? Just because there are so many different items. And the last thing is there is essentially no adverse selection, or if you prefer, there is no issue of finding of needing to try the product. Okay, so you don't actually you don't need to see the product physically to know it's the right one. You know, a book is a book. If you have the right title, then that's it. So because of that, he selected books as a starting place. But if you read what he had in mind, it's very clear that from the very beginning, the point was, well, people are going to come to Amazon, but the reason they're going to come back is because we're going to offer them the book they want, plus suggestions about stuff they might want to read. In other words, we're going to offer them the books they don't know yet that they actually want. And that was there from the very beginning. Okay, so now I'm not saying that these are the only two key features of this large platform. There are other things, but we believe these two are very important. You know, like a very efficient matching function together with a very efficient way of collecting data. And so we're just going to say, okay, suppose we put these features together and we ask what happens. Yeah.
Yeah, can I add one point? Because what you mentioned here seems to me that the platform has some technology to kind of augment the demand, right? Yeah. It's not really the kind of the data. Actually, they kind of augment the demand in a way that previous, let's say, traditional retailers cannot do.
Yeah, but the way they do it is by targeting advertisements, by proposing to buyers the kind of goods that they might be interested in, and all of that is based on information.
Yeah.
So the key things is they get the information. Okay, so now let's be a bit more precise. So in this paper, we're gonna ask essentially three questions. How does data gathering affect buyers and sellers? Okay, the fact that the platform. So we're gonna have three key players, right? We're gonna have buyers. So, the model, of course, deals with transactions. So you could map into many different types of model. But just to be concrete, think of it as the buyers are households, the sellers are merchants, and the platform is in the middle. Okay, so think of a large retail platform like you have in China, like we have in the US. So first, how does data gathering affect the buyers and the sellers? Second, is there a case for regulating data collected by platforms? Is there a reason why data would be either it would be too little data or too much data? And in answering that question, it turns out that we also be able to explain how the new internet platforms differ from more traditional ones. Because if you look at what the platforms actually do, there's nothing they do that was not done before by large retailers in physical stores. Gathering data on your consumers, well, retailers have been doing that since they were first invented. You know, they had address books and they had all the information they could gather on their customers since the 19th century in Europe. Selling their own brands, same thing. If you go to any kind of large retailer, you're going to find the famous brands, but you're also going to find the retailer's brand. So none of that is actually new. And so the question is, okay, but then is there something new then with the internet platform? And it's going to turn out in the model that there is something new, but it's more like it's a mixture between quantitative and qualitative features. The model would predict why when you quantitatively change some parameters, then you can have qualitatively different results for data gathering. So more precisely, so the first question, how does data gathering affect buyers and sellers? Well, the first thing, of course, it's good. Okay, obviously, data gatherings improves the efficiency of trade because, so in our case, the uncertainty, the taste uncertainty is going to be on the buyer side. So the buyers want different types of product and nobody's quite sure what they want. So if the platform finds data to make recommendations that are useful for the buyers in choosing the product that they actually prefer, then obviously you're going to increase the gains from trade, and that's going to be good for everybody, because this is like exactly equivalent to increasing productivity in that sense. So that's obviously good. But the key trade-off in our model is that this data aspect is going to increase the market power of the platform vis-a-vis the sellers. Okay. So that's going to be the key trade-off in our model. Data is good because it improves matching, but data can be excessive to some extent because it's going to increase the market power of the platform relative to the sellers. Is there a role in regulating data collected by platforms? Yes, if we are in the space, and that's where the qualitative and quantitative are gonna interact. In the model, it's not always the case that there's too much or too little data that is shared. In some cases, there is too little actually. In some cases, there is too much. But so when there is too much, there is an incentive. It would be more efficient to limit the data gathered by the platform, because when the platform gets too much data, then it can act as a gatekeeper for the sellers. The sellers essentially end up with no choice. If they want to be able to access the customers, the consumers, they have to go through the platform. So that essentially gives the platform a very strong market power. And then the platform is going to be able to extract a lot of the rents from the sellers. But that means that sellers then are going to be squeezed out, and fewer sellers are going to enter, which is bad for consumers. Okay, so the chain here is, yep.
So here you mentioned that if the platform gather too much data, then they will have a larger market power relative to sellers, right?
Yep, yep.
But from a social point of view, so do we really want to have this market power shared kind of equally between the platform and sellers? Is there a trade-off or?
Well, so here we're going to have the limitation of what we do. There are two. I might as well say it now. So there are two limitations to the analysis. There is two things that are missing from what we do. The first, and they are of course, and they are very connected. The first is that we don't look at the issue of single versus multi-homing. That is, there's only one platform, and well, it's not exactly true because we have an outside market, so the consumers will be able to choose where to trade. But the issue of single homing is a strategy by the platform to offer enough goods so that the sellers always go to the platform first when they look for something. That is important, and we don't model that part directly because we don't have repeat goods, or we don't have my consumers are going to buy one good. Okay, so there is no sense in which they buy a lot and therefore they always go to the platform first. The second thing that we don't model is platform entry. That is, we assume there is one platform. We don't endogenize the entry of the platform. Okay, so then for your question, what would be the right way to share market power? Well, more competitive, the better. But here, because the platform is there and seller entry is the variable that's going to adjust, market power by the platform is bad, because if sellers if the platform takes away the profits from the sellers, just fewer sellers are going to enter. Okay. Now, of course, if you had to model platform entry at the same time, then the platform also will need to recoup some, and then it would depend on the technology you write down for entry by the platform. The key point here is that everything I'm going to show you would still be true, because what we have here, it would always be part of a more complicated model. It's just that on top of it, you would add some features. Okay, and then now, what's the difference between going to the supermarket and buying on a platform like Alibaba or Amazon? Well, it turns out that whether or not you're in the range where there's too much data gathering depends on how efficient the matching function and the data gathering functions are. So if you thought that in the past, data gathering was kind of slow because it was based on your name, maybe your credit card and a few things like that, and it was very limited, and typically the sellers only observe the small fraction of what you buy. Today, it's very cheap. So the data gathering is much faster. Then this is going to make it more likely that we can be in the range, in the space, the parameter space, where there could be too much information sharing. So that's how we're going to answer the 3 questions. Okay, so then before we jump into the model, just one thing. How does our model differ from the more traditional or existing models in I/O? The main difference is that we don't assume the network effect. We don't assume the inefficiencies that can come with it. Like the typical I/O, if you think about Roche-Tirol or the paper by Armstrong, and the typical paper in I/O, they write matching functions where the number of matches is like quadratic. So it's like you multiply sellers by buyer. So one way to think about it is if say you're a buyer, then your value is going to increase linearly with the number of sellers and will not depend on the number of buyers. So there are some cases like dating agencies and stuff like that, or nightclubs, where that could make sense. Maybe credit cards sometimes, but for many of the retail stuff, it doesn't make sense, because assuming that as a one buyer, all I care about is number of sellers, not the number of other buyers. Is the same thing. I think that there is no competition. So like if I'm alone buying stuff, or if there are a million other buyers, then that doesn't change anything for me. That is not a realistic assumption for almost all of retail trades. Now, with credit cards, could be, but for many of the applications we have in mind, that's not a good assumption. So we go exactly the opposite. We take the more traditional macroeconomic matching function, which is constant return to scale. Okay, so that does not assume any inefficiency. That does not build in any increasing returns or network effect, just the matching function. And then we see what happens. Okay, so I think that's the main difference. There is nothing that's hardwired to be inefficient in our model. Okay, so I think that's the big picture. That's the main difference between what we do and some of the I/O literature. The other difference, of course, is the fact that we have competition between 2 marketplaces and that we have data gathering. Okay, so let me summarize the model so you can see how it works. So I think I already said everything in terms of the big players. You have the platform, the buyers, and the sellers. But of course, the platform is not alone. So the buyers and the sellers can also trade in the outside market. Now, this outside market, I think the simplest way to think about it is, imagine this is a physical retail store. Okay, so you can go to the physical retail store, the old-fashioned way, if you want. And that's what people had been doing for a long time. And in the physical retail store, you can find the product that the sellers sell and buy them. Okay, so this outside market here is going to be the traditional market. And buyers and sellers can always meet in the outside market. But they don't have to, because now there is also a platform. And if the platform is efficient, that is, if the matching function on the platform is good enough, then it's going to attract some buyers. Okay. So the first decision is going to be the buyers they want to buy one item. Okay. So remember, that's what I said earlier. You would want to extend this kind of model to have either repeat buying, or I think more importantly, to buy many types of goods. And then you could have the issue of single versus multi-homing. Here, it's each buyer wants to buy one unit. So it's only one choice. They're going to try to buy the unit on the platform or in the outside market. In equilibrium, we're going to have buyers on both sides. Okay, so some buyers are going to join the platform, some are going to join the outside market. So obviously, you can imagine what's going to happen. There's going to be a value function for joining the platform, a value function for getting on the outside market. And in equilibrium, these two value functions would have to be equalized. So the buyers are indifferent between the two. The difference between the platform and the outside market there are two differences. They have exactly the same matching technology, matching elasticities. So the parameter, the power exponent in the Cobb-Douglas function are the same, but it could be that the platform has a higher efficiency or lower efficiency in terms of matching. So that's possible. That's one possible difference. The more important difference is that the platform also gathers information about the tastes of the buyers. So this is going to take the form of a disclosure parameter delta. And delta is the precision of the signal that the platform is going to get about the taste of the buyers. Okay, so you can think of it as delta is jointly decided by the buyers on the platform. So here in the model, we just assume the buyers decide how to set delta. So the buyer is going to either accept or refuses to be tracked with various types of cookies, accept to share more or less information with the platform. So that's a choice of how much information to disclose. And there's also a technical limit, which is, before the internet, even if the buyers wanted to disclose a lot, there was a limit on what they could disclose. Okay, then the sellers on the other side. So the seller, they want to do is meet the buyers, okay? And they know they can meet the buyers on the outside market or on the platform, okay? Now, some sellers are already in the outside market, okay? So there's a mass of sellers that are already created their, if you want, their physical retail space. And so they will stay in the outside market. But new sellers can enter, and the new sellers who are going to enter, I will choose whether to join the platform or the outside market. Okay. Now, in the outside market, it's going to be a simple matching function. They're going to meet with buyers and then trade. On the platform, it's also going to be a simple matching function. They're going to meet with the buyers and trade, but they also buy from the platform the information flow. Okay. So the disclosure, that's delta, that's the precision of the signal. The realized signal is sigma, okay, about the taste of the buyers. So when the sellers trade on the platform, they also buy information about the buyers. That's going to allow them to propose to the buyers the goods that are more likely to be the ones that the buyers want. Okay. So I guess that's the whole model. Once they match, the kind of interaction between buyers and sellers is the same on the platform on the outside market. Okay, so I think now we can go into the details. So the first thing we need to do is we need to introduce some uncertainty about the taste of the buyers. Okay, because if there is no uncertainty, then there is no value for information. So we need to introduce uncertainty about the tastes of the buyers. The simplest way to do it, okay, is to assume that there are J, there is a set J of, or big I if you want, of goods. The number of goods is big I. Okay. So you could buy the variety of goods, 1, 2, and up to I. And the thing is, you don't know in advance which is the one that you like. Okay. So formally, you dislike all of them except for one. So there is one for each buyer. There is exactly one type of good that gives utility U to the buyer, and all the other ones give 0. Okay. So you would never want to buy the other ones. But if you find the good one for you, then you would be willing to pay a maximum of U. Okay, now the disclosure of information is a choice of a parameters, delta, between 1 over I and delta upper bar, such that when the signal about the taste is sent, the precision of the signal is delta. Okay, so delta is between 1 over I and delta upper bar. So delta upper bar, that's a technological upper bound. Okay, it's the maximum you could disclose. Okay? So it's less than 1. 1 over I, of course, well, because that's a pure random. If you have no idea and you choose randomly among the I goods, well, the likelihood that you get the right one is 1 over I. Okay, so clearly that information cannot be less than 1 over I. The signal precision is delta. What that means is that the probability that the signal sigma points to the correct I, conditional on I being the right one, so I being such that UI is U instead of 0, that's delta. Okay, so delta is the probability of getting the right signal. And because we assume that the initial distribution across the variety is uniform. Okay, so ex ante, you don't know, and each one has a probability 1 over I to be the right one. Then delta, if you apply Bayes' law, you will see that delta is also the probability of the right good. Okay. All right. And the last thing, of course, the outside. Remember the difference. The outside market doesn't have the information flow. So another way of thinking it is on the outside market, delta is equal to 1 over I. Okay. All right. So that's for the buyers, and the number of buyers is NB, N bar B. Sellers. Well, so sellers, the difference between buyers and sellers in the benchmark model is we take the buyers as given. So they are here. There is a mass of buyers, NB bar. The sellers have an entry decision. Okay, so there's an entry cost kappa. If they enter, they can sell 1 unit of the good on either on the platform or on the outside market. They can buy the data. Okay, so buying data means you buy the precision and the signal. And for that, you pay a price M to the platform. Okay. And then you decide which variety to produce. So on the platform, you get the signal delta, sigma, sorry, with precision delta. So if you follow the signal, okay, if the signal says for this particular buyer, the signal is 3, then you're going to produce good number 3. And the probability that this is indeed the correct variety is delta. Okay. On the outside market, the probability is 1 over I.
Thomas, I have a clarification question. So here's about the data. So is this so when the sellers buy data from the platform, is this data personalized data or aggregated data? So the kind of sellers know so this is some data from a specific consumer or just know the aggregated thing?
No. It's from specific consumers.
Okay. So
you can, I mean, the simplest way to think of it, this is, of course, in the real world, where they don't really buy data, they buy advertising technology or targeted ads. So they pay for, they pay for, I'd say, for instance, on Amazon, if you look at the big sources of revenue, it's you bid on keywords, and then you bid on, and then you buy space so that you are at the top of the list, and you're recommended. So these are the things that you buy, and then it's tailored to the consumer, because these things are going to show up when a particular consumer does a particular search.
So do the consumers know their preference? Maybe they also don't know that information, the taste. So here the consumers.
So the consumers don't know. They don't know it ex ante. So when they choose Delta, they don't know it. But when they see the product, they can recognize whether it's the right one or not. So at the time where they trade, at the time where they interact with the buyer, then they will know whether it's the right product or not.
Okay, yeah, I will wait to see some more details of the setup. Thank you.
Okay, good. Okay, and then the buyers and sellers interact in competitive search markets. Okay, so that's the part which I think is actually, at least it should be the starting point for this kind of papers, which is you start with competitive search. So competitive search is efficient. Okay, you don't build in inefficiency in there. Okay, so
Professor, can I ask one question on the entry cost? So one thing we will usually imagine that opening a store on the e-commerce platform is much less costly to compared to opening a real one, right?
Yeah. Well, so yeah, it depends if I guess it depends how you interpret the sellers. If you think of the sellers as being producers, then I don't think it changes much, because they have to. The cost is the cost of producing the good, and then to sell the good.
Usually it's the retailers, so it's kind of matters a lot rather than store.
Yeah, but here the platform is where the retail takes place. For the producer, for the sellers, if you think of them as producing the good, so the kappa is like the entry cost to be able to produce the goods, then that's not specific to the platform. But I agree with you. You could also interpret kappa as being a cost that you pay to be able to deliver to a particular location. So for instance, if you sell your product in the supermarket, then you need to at least be able to send the goods to that supermarket. So maybe, and if you want to switch to sending to a different supermarket or to a warehouse owned by the platform, there might be a switching cost. That's true. But I think for now, just imagine kappa is just literally the cost of production for the sellers. Okay, so the matching technology is going to be standard Cobb-Douglas with exponent gamma and 1 minus gamma. Okay, so if you have NB buyers and NS sellers, then the number of matches is going to be proportional to the product of NB and S with the NS to the power 1 minus gamma and B to the power gamma. Now, as usual, like in labor matching functions, this thing has constant return to scale, so you can define the ratios. Okay, so for instance, the probability that a buyer meets a seller. Okay, so this is from the perspective of a buyer. Alpha of n is alpha bar. So alpha bar is the productivity of the matching function, and n is the how tight the market is the market tightness. So here would be NS over NB. Okay, so if you are a buyer, if NS is high relative to NB, then you're more likely to meet a seller. Okay, if there are more sellers relative to buyers. Okay, so that's in IO. Oftentimes people assume that essentially they assume away this NB at the bottom here. There is no congestion effect, but I don't think it's a good assumption when you think about retail. So okay, so this is Cobb-Douglas, constant elasticity, and causal return to scale. Okay, we have, that I already explained, delta bar. And the platform sells the consumer data to the sellers. Okay, so we're going to have to determine the bargaining between the platform and the sellers. On the outside market, it's all the same, except for two differences. The first is there are already some outside sellers. So the thing of the outside sellers are the ones who already they are used to selling on the traditional market, and so they will continue to do that. And so there is an exogenous mass of sellers in the outside market, n bar 0 or n by O for outside. The matching technology is the same, except we don't have to assume that alpha is the same. Okay, so that's what I was saying earlier. Like if you think about purely as a matching function, the search function on Alibaba or on Amazon is typically it's faster and more efficient than looking physically for the good. So that's the same thing as saying alpha bar here for the platform would be higher than alpha bar 0. Okay. So the total, this is like that's the TFP of the matching function. So TFP could be a bit different between the two functions, but otherwise the same elasticities, everything is the same. Okay. So on the outside market, you also have a market tightness, and you have the same kind of functional form. Okay, so let's do it step by step. Yeah.
So I'm wondering, where is the price effect? Because on the things on the outside market are usually a little bit more expensive than the online products because the online store operates at a lower cost. So chances are that consumers find the product in the outside market, but they do not buy from the outside market. Well, in return, they buy the same product by searching online, and this induced search online is coming from the price effect. But
yeah, so I agree. So initially, I agree with you. Initially, so I guess so. The answer here it probably depends a little bit on the specific market you're looking at. If you look today at the majority of goods, I know more the US, so I'm not totally sure in China. But if you look at the US market, the prices are essentially the same. The prices are essentially the same on, say, Amazon versus going to the store. And the main difference is if you buy on Amazon, you don't have to go to the store, so you save a bit of time. You save the trip to the store. And of course, the advantage of the outside market is sometimes you can actually see the product to make sure it's the right one. But that initially was important because the platform online didn't quite know exactly how to give enough information so people know for sure that they're buying the right product. So I agree with you that initially there was this effect, which is, you needed to verify the product. So some people would go to the store to find the product, make sure that they know, okay, that's the one I want. Then they would go home and buy it online because it was a bit cheaper. I think that effect is much smaller now because the platform online have figured a way to show the product the way they are. And so but in our model, to be clear, the price is going to be exactly the same online and in the outside market. I agree with you that there are some cases the price could be a bit different, but in our model, it's going to be exactly the same.
Thank you.
Okay, so
Thomas, I have two additional questions. Probably both of them are clarification questions. The first one, so I understand here you assume the buyer can only consume one unit, so they might just choose either outside the market or the platform. But the sellers in principle can sell multiple products, so they can choose to go to both, right? So here you assume they can only choose one, so either platform or outside the market. So I'm thinking, so if they can sell multiple goods, they can in principle they can go to sell online and do the real kind of outside. Yeah.
No, so I completely agree. So that's completely true. In our model, that's not going to happen. But it's because the model is very simple and it doesn't have, if you're building more heterogeneity, you would get that because you would have different, like it's not clear, but you could get that if you have more. If it's not the same buyer, if the buyers who buy online and the buyers who buy in the physical store, they are different in more than one dimension, then as a seller, you want to reach. Say they are like demographics. Okay, they are not the same demographics. Then to reach all of the demographics, you would maintain a presence in the retail store and you would sell online, and that would happen in our model. Here, I don't have enough heterogeneity. So it turns out that in this model, once the sellers prefer the platform, they all go to all the new sellers go to the platform. And on the outside market, you only have the old sellers that are left. But it's a bit of a knife edge. It's just because there is very little heterogeneity across buyers, and have exactly constant return to scale. So when the platform is more efficient, everybody goes to the platform. That's a bit extreme. I agree with you.
Yeah. So yeah, maybe it depends on the matching technology. Yeah. My second question is related to your opening remark. So here, this alpha and delta, they are exogenous parameters. And you mentioned that, so that the new kind of new platform differs from the traditional market because of two things. One is kind of the larger market. The other one is like the data thing. So I'm thinking about whether there is kind of interaction between this alpha and the delta. So maybe.
Yeah, there is. You will see it. Yeah. Exactly. You're exactly right. You will see, in fact, on the next slide, you will see the interaction between alpha and delta.
Okay. Yeah. You're
exactly right. Okay. So, So to keep it super simple, like we're going to look at the case. We're going to forget the platform for 2 slides and imagine the world where it's before the platform exists. Okay, so you only have the outside market. So you have buyers, sellers, and one outside market. Okay, just to set the stage. So then it's really easy. It's just that's a pure standard competitive search model. So you can have buyers and sellers. The equilibrium price and equilibrium market tightness are going to solve the maximization problem, if you want. They maximize. So you can write it in many different ways, but because it's competitive search, it's equivalent to the seller maximizing output or profits subject to a participation constraint by the buyer. Okay, so that's what this is saying here. All right, so for the remember they've paid the price kappa before to enter. That's like the fixed cost. We don't put we don't add marginal cost because we don't need it. So so that means their profits are equal to their sales. So sales are what? Well, there are 3 things. The first is, do you meet a buyer? Okay, so that's alpha of n. Okay, so that's the value function for the seller. First, they need to meet a buyer. Okay, so that's alpha of n. Then they need to propose the right variety. And in the outside market, you don't know. So the chance is 1/i of getting the right variety. And then finally, there's the price at which you sell. Okay, so that's the total, that's the expected profit as a function of market tightness and of the price. The buyer's outside option, or the buyer's value function, if you want, is very similar, except of course, the probability of a buyer meeting a seller instead of alpha of n is n times alpha of n, okay, like in any Cobb-Douglas function. So that's the matching probability from the buyer's perspective. So obviously market tightness goes in different direction for this guy. And so alpha of n is decreasing, but n times alpha is increasing. So that's the tightness from the buyer's perspective. 1/i, that's the same, okay, because that's the likelihood of having the right match. And then the consumer surplus is u, which is the value of the good variety, minus p. Okay. Well, so now you maximize that, and then but we already know the answer because that's the Cobb-Douglas. The price is going to be equal to 1 minus gamma times u. Okay, where gamma, you remember, is the coefficient in the matching function. So it's a classic result where you split the surplus gamma 1 minus gamma. Okay, so surplus is U if you trade. The consumers are going to have gamma times U, and the sellers are going to get 1 minus gamma times U. Okay, that's how they're going to split the surplus. If you only have the outside market, then by definition, the buyers can only go to the outside market. So the number of buyers is going to be the total, N bar. The number of sellers is going to be the existing one plus a new entrant. And the new entrant is going to solve the free entry condition. Okay, so the value of being a seller, you just replace for the equilibrium price in this thing. Okay, so P is 1 minus gamma times U. Okay, so you plug it into that function, and then you get 1 minus gamma times U. Okay, and then you get that. So this is the equilibrium value function as a function that depends on market tightness, and that's equal to the free entry condition. Okay, so in this model, of course, what that means is that the market tightness will be a function of the entry cost. Okay, that's free entry. So the sellers will enter up to the point where the value of entering is equal to the fixed cost of entry, and that will pin down the market tightness. And standard arguments imply that equilibrium is efficient. That's, you can see it here. The equilibrium is efficient because the price, so the share of the surplus going to the seller is 1 minus gamma. But 1 minus gamma is also the elasticity of matching to the number of sellers. And that's the efficiency condition. Okay, so this is just a classic competitive matching, competitive search model where everything is efficient. Okay. So we're going to start from this, and now we're going to introduce the platform. So we keep the outside market, but just introduce the platform. Now, if the platform is not very efficient, then of course it will not be active, which means everybody's going to stay on the outside market and nothing is going to change. Now, imagine you start from this situation and you start to increase the productivity of the platform, either by increasing alpha bar or by increasing delta bar, or both. At some point, the platform is going to be efficient enough that it can compete with the outside market. If the platform is active, that means there are some buyers on the platform. That means the buyers must be indifferent between the market and the platform. Okay, so we're going to solve the same model, except that we're going to impose the indifference condition for the buyers. Okay, so competitive search between buyers and sellers in the outside market and on the platform, the bargaining point between the platform and the sellers, and then the disclosure choice by the consumers. Okay, so let's start with the competitive search on the platform. It's the same as before. Okay, it's the same because the technology is the same up to the productivity alpha bar. Everything is the same as on the outside market. So you know that on the platform, the price is also going to be 1 minus gamma U, just like in the outside market. So the price is the same. And the value function are going to be given by the same kind of formula we saw earlier. So for instance, this is the value of the seller on the platform. Okay, so when there was only one market, it was this thing. So what's different now? Well, it's still 1 minus gamma U, but this is for the outside market. On the platform, the differences are, this is N, that's market tightness on the platform. And this is not 1 over I anymore, it's delta. Okay, because the likelihood of finding the right variety is not 1 over I, it's delta on the platform. For the buyer, it's the same kind of function, except the share of the surplus is gamma times U for the buyer. And then the market tightness, of course, goes the other way. So this is N to the 1 minus gamma for the buyer. All right, so that's pretty straightforward. So the first thing that's a bit new now is how do we determine the price of information? So we're going to assume that the platform bargains with the sellers. Now, there is many ways you can write this bargaining. In the paper, we consider 2 or 3, I think. Nash bargaining, I think that's the simplest one to start. And we also solve for the monopoly case, where the platform act as a monopoly. take it or leave it out offers to the sellers. It doesn't really change much. So I think the Nash bargaining is simpler. Okay, so the sellers and the platform need to agree on how much to pay for information or for the right to trade on the platform. So we're going to solve that as Nash bargaining. So first, we have the surplus of the platform, well, that's the fee, M. That's how much the platform charges relative to the outside option of the platform. And I will specify that in one slide. You can set that to 0 for now, but I'll tell you what we have in one slide. For the seller, what is the surplus? Well, it's the value of the seller on the platform minus the fee minus the outside option. Okay, because the seller can already go on the outside market. So that is the most important thing in the paper. Okay, see, in this Nash bargaining problem between the platform and the sellers, the seller outside option here on the outside market enters in the bargaining problem. So if this outside option of the seller is high, the platform cannot charge a very high price. Because the seller can say, well, if you charge too high, I'm just going to go sell on the outside market. It works fine. I can get the consumers there. So if VSO is high, M cannot be very high. On the other hand, if VSO is low, then N can be high. Okay. Well, it's Cobb-Douglas Nash bargaining, so it's pretty straightforward. You're going to get the weighted average. So the price that the platform is going to charge is going to be a weighted average of the outside option of the platform and the difference between VS and VSO. Okay. So again, if VSO goes up, M goes down. Okay, because the sellers can tell the platform, look, we don't have to sell online on your platform. We can go sell somewhere else. If your price is too high, we're going to go somewhere else. Okay. The question is that threat credible or not? That's going to depend on the outside option. So what are these outside options? So we're going to have two outside options that are going to be important in the paper. One for the platform and one for the seller. Maybe the one from the seller is actually simpler. This should be written the other way. Let's do the seller first. That's just, the value of the seller on the outside market. Now, we saw that thing before. We know what it is. Okay, it's 1 minus gamma times the surplus they get by trading on the outside market. Now, the key thing, of course, is trading on the outside market is attractive if there are a lot of buyers on the outside market. Okay. If all the buyers are on the platform, then trading on the outside market is not great because there are no buyers. Okay. But if that's the case, then the value function here would be low, which means then the platform would be able to charge a high price. So this we call the gatekeeper effect. Okay. So if in our model, because of information, if the platform becomes really good at information, or if the consumers are willing to give a lot of information to the platform, then trading on the platform becomes very attractive for the consumers. So all the consumers go, not all of them, but a large majority of the consumers go to the platform. But that means that there are very few consumers left in the outside market, and the sellers have a very low outside option. Okay, that's going to be the key mechanism. So that we call the gatekeeper effect. Okay, gatekeeper, because what happens is that the platform de facto becomes a gatekeeper to access the consumers. If you don't trade on the platform, you can't reach the consumers. The other thing that's going on is the outside option of the platform. So this one, depending on the application you have in mind, may or may not be important. Because initially we were motivated by looking at what Amazon does, and I'm sure you've seen the discussion in the news and the antitrust cases. A lot of them are about Amazon's own brand. Okay, so the fact that Amazon can, if Amazon sees a product that sells very well on its platform, it can create its own copy of it and sell it and compete with the sellers. Okay, so we thought because people discuss that, it's important to also model it. So that's what we did here. We call that the copycat effect. And it's the fact that the platform can literally just replicate what the other sellers are doing at some cost, C. So C is the cost of the platform of producing the good. And C is positive, so it's not efficient for the platform to produce the good itself, but it can if it's forced to. Okay, so again, in this model, because there is no asymmetric information, in equilibrium, the platform will actually not produce anything, but it can threaten to do it to charge a high price. Okay, so these are the two outside options: the outside option of the platform and the outside option of the sellers. And the thing that's important is in both of these outside options, you have delta showing up. Delta shows up in the outside option of the sellers, because if delta is high, then tightness on the outside market is going to be low. Okay, because all the buyers go to the platform. Delta also shows up in VM, because if delta is high, it's easier to create a copycat because you know exactly which one to create. Okay. All right, so now I think we see everything. So the seller's value on the platform, net of fees, is what? Okay, so VS minus M. You have, so first VS, well, you get a fraction 1 minus gamma of the gains from trade, fraction 1 minus theta of that because of bargaining with the platform. The gains from trade themselves increase in delta. Okay, delta goes up, the market is more efficient, you're more likely to trade. So that's the first effect. If delta goes up, it's going to increase this part. So that's good for the seller. The second part here is the impact of delta on the outside option, okay, because of bargaining. That's where delta could be a problem. If delta is too high, so if information is too high, then the outside option of the platform or the outside option of the seller are going to adjust in such a way that the platform is going to be able to extract a higher surplus. Okay, so that's the trade-off I was telling you earlier. A higher delta, so better information about consumer taste, has two effects. The first is it increases market efficiency, gains from trade. The second is it increases the market power of the platform relative to the sellers. And that might discourage entry. Okay, so to finish up the model, we have two things. Okay, so we have just like before, we have a free entry condition for the sellers. Now, before, the free entry was just VSO, the value of the seller on the outside market, equal kappa. Now, of course, it's VS minus M equal kappa. So that's the free entry condition for the sellers. And the second equation to solve the model is the indifference condition of the buyers, which says that they get the same value on buying on the platform or on the outside option. Okay, that's going to adjust the market tightness. Yep.
Can I ask one question on the competition between the platforms? So here you mentioned that if the precision of information is better, then the market platform can extract more surplus relative to sellers.
That's
but
right.
Actually, if you think there is a competition between the platforms, then this price, this competition between the different platforms will drive down this price, right? Then actually it's good for the sellers. They can choose between different platforms, and now the platform, all of them have a better technology, and they can, yeah.
That's right. No, so if you could find a way to have the efficient part of delta, which is the gains from trade, without having the market power, that'd be great. So one way to do it, if it's possible, would be to have several platforms competing. For sure, that would be efficient. But then the problem becomes, is that an equilibrium? And to analyze that, you need to analyze platform entry and and as I was saying earlier, together, the two things that matter really, entry and single homing. And so we haven't done that in that paper. Here, I think it's going to boil down to some notion of free entry for the platform and how big are the costs. So if you think of, you can write that model, for instance, where there's a fixed cost for the platform to enter. And if you pay a higher fixed cost, you get a higher alpha bar. This kind of model is going to be hard to have two platforms, see, because they're the better one is going to attract almost everybody. So, but apart from that, I completely agree with you that the first order thing to understand here is the role of, or the question of whether you can sustain competition among platforms. That's agree. That's totally.
So Thomas, I have a quick question.
Yeah.
This is again outside your model, but that would be, when would it pay the sellers to set up their own platforms? Is that something? I mean, that's outside your model because you have one platform. But is that something maybe large sellers would try to do under certain conditions? I don't know. How do you think about that?
Yeah, but so that's a question that has been so first of all, in the model, yes, it would be very similar to the previous question, which is you would need to think about platform entry,
right,
and the issue of single homing, which is, are the consumers going to go to your platform first? For the sellers, I think that you could imagine a team of sellers getting together and creating their platform. In practice, we haven't seen much of that, and I think it's just because you would have free riding issues. What we've seen is that some brands decide, the brands that have a high brand value, sometimes they refuse to sell on the platform. So for instance, like on Amazon, you're more likely to find relatively cheap sneakers than Nike shoes. Or the best example, Apple for a long time didn't want to sell on Amazon because he wanted people to go to the Apple stores. And now it's selling a bit on Amazon, but still not very much. But Apple has a big enough brand that they can afford to sell their product without the platform.
Yeah.
And the reason, of course, is because if people look for an Apple computer or Apple or an iPhone, they know where to go. They would go to the Apple store.
Right.
So therefore, that kills the single homing issue. The problem is for everybody else, where okay, today I want to buy a pair of sneakers, or I want to buy a tool for working in my garden or for repairing something in my home. I don't know the brands don't really. I mean, there are some brands, but they are not so well known. So I'm going to go to a general purpose platform and do a search.
Mm-hmm.
As soon as that happens, it's going to be very hard for this type of sellers to create their own platforms because nobody's going to go. That's the main issue.
That's Amazon. That's the Amazon model in a way, right? These smaller sellers just go to Amazon. Yeah.
Absolutely.
Thank you.
Yeah, and also I want to add that actually for the kind of very successful brand, the bargaining power of them is very high when they try to bargain with the platform, right? Because actually platform want to have them on the platform and to attract more customers from their customer base.
In fact, but that's exactly right. And again, that's my point, which is to understand that dynamics. You really want a model of single homing, because like you could imagine a platform saying, if you think for the platform, the most important strategic goal is to get as many consumers to single home as possible. Okay, so for people to single home, they need to be convinced that whatever they are looking for, they will find it on your platform. So for the platform, it might, if there is a famous brand that people would know, the platform might be willing to give a very low price for that brand just to be on the platform, even if they don't sell a lot, actually. Just purely for the fact that the consumers know that they can't find that brand there. Even if the actual volume of sale is very low, even if the brand does not pay a high price to the platform I want to have the brand precisely to make sure that everybody knows that they can find everything on the platform. These are super, and these are very important effects. And again, we don't have them here because you need to model single versus multi-homing to get that. Okay, so let's see what the equilibrium condition look like. it's pretty straightforward.
And Thomas, I have one additional question. Could you please go back 2 slides? So I have a question. Here. So about the delta thing. So I assume the delta will be indulgence later by either the platform or the buyer's choice. So
it's going to be the buyers, the consumers who choose it.
Yeah. So here, I think when the platform sells the data to sellers, maybe so after the platform collects data, may sell part of the data to the sellers. So I mean, so maybe that kind of sort of 2 deltas. So one delta is the amount of data sold from the platform to the seller. So that will determine something like the matching efficiency or something like in the first term. The other one is the data kept by the platform itself. That will determine the kind of the market power of a platform. Because I have better data, I can extract extra rent from the seller. I can kind of thread. I have a better matching technology than you guys.
Yeah, I agree. But it's like I mean, what the so in the model, it's a bit reduced form. Like we have a signal. So technically, what the platform sells is the signal, not the data itself.
Yeah.
So essentially, the platform is saying, okay, this is a good consumer for you, or is telling the consumer, this is a good seller for you. That's what this is about. And you could interpret it as the platform sells that piece of that signal, that piece of information, but keeps the data underlying it. It does not tell you why it's a good consumer. It doesn't tell you how it knows that. It just tells you it's a good match.
Yeah, but the platform can, when I tell the signal to the sellers, I can add noise. I know this, to me, I know this is a good consumer. I can produce good things for, produce good match for this consumer. But when I tell the seller, I add some noise. I try to confuse it.
Yeah, but that's the difference with, are you sharing raw data or are you sharing the end product? If you share the end product, then you have no reason to add some noise. The reason you would add noise is because you don't want somebody else to be able to reconstruct your data. And so if that was a concern, that they would definitely do that. Here, they don't have that issue because they sell directly the end signal. So, all right. So remember, you have 2 key conditions, the free entry condition and then the consumer indifference condition. So then you can combine them and then you get the equilibrium tightness. Because remember, that's a standard matching model. So the key, it's exactly like a Mortensen P-Sides labor search model. Okay, the key variable is the market tightness. So N. So market tightness is going to depend on gains from trade, obviously. So the higher the gains from trade, the higher the tightness. That's just the standard productivity part. And then you have this ratio here of the matching and match efficiency relative to entry cost plus copycat effect. So if delta goes up, what happens? G is ambiguous, VM is always going up. Okay, so the copycat effect, if delta goes up, VM goes up, market tightness goes down. That one is never ambiguous. Okay, if delta goes up, the thread point of the platform to create copycat is stronger. You will be able to extract a higher surplus from the seller. The G at the top here, that's ambiguous for the reason we saw earlier. This function here has 2 parts. It has the market efficiency part. So if delta goes up, it's more efficient. That's good for everyone. But it increases the gatekeeper effect. So the gatekeeper effect says that if delta is very high, matching the consumers know that they are very likely to find the right product on the platform. So all the consumers go to the platform. That depresses the outside option of the sellers and therefore allows the platform to charge a higher fee and depresses entry by the sellers. So that's the gatekeeper effect. And of course, now you see it's ambiguous. So whether G is increasing or decreasing in delta depends on where you are in the parameter space. Okay, so then you can find a function such that market tightness decreasing with delta if and only if this is negative. Okay, so then this is like that whole thing has to go down, either because G goes down or because V goes up quickly enough. Okay, now if you look at the parameters, that's more likely to happen when theta is large or when gamma is important. Okay, so that governs the gatekeeper effect. Okay, now what about choosing delta? So here you can think of, there are two ways you can think of it. You can think of it as purely as a technological parameter. So delta is anywhere between 1 over I and delta upper bar. Or you can think of it as involving some private costs for the buyer, and then they optimize with respect to delta. Their value function net of the disclosure cost. Okay. If you write it like that, it nets all the cases, okay, because delta bar is in the constraint here. So this is both a matter of preference and technology. Now, the thing that's important is this guy here, VB, is always increasing in your own delta. Okay, if you're a consumer, if you take as given market prices and market tightness, you privately always want to, your VB function is always increasing in delta, in your own delta.
Sorry, I have a question.
Yeah.
Why a consumer would keep, well, I mean, what is the incentive for a consumer to share his private information? Generally, more private information, more rent. So why should I
that's the
give
thing.
up?
So the consumer here does not get tricked by the platform. See, the given prices, given the market equilibrium, the consumer always wants to disclose the maximum amount of information because it's going to increase the chance that it will get the right recommendation from the platform. That's privately optimal for the consumer to disclose a lot. Now, you could add a private cost here, so maybe they will not go all the way to delta upper bar, but they would still go very high. Okay, in the sense that this VB stuff here is always increasing in delta. The partial derivative with respect to your own delta is always positive. And that's going to be the key difference between the planner and the consumer. Okay, so this derivative here is this, it's always positive. And so you could have an entire solution where this is equal to delta prime, or you could be stuck at the upper bound delta bar. Okay, now that knowing delta, then we can solve for the model. Okay, so now you have two equations to unknown in market tightness and delta, market tightness and delta, two equations to unknown, you can solve for the equilibrium. But the key here is the buyers don't internalize the effect of their own disclosure on market tightness. See, so as one buyer, I want to give information to the platform because then I'm more likely to get the right product recommendation. If everybody does that, then the platform becomes super efficient. All the buyers go to the platform, and then the sellers' outside option goes down. The sellers' entry goes down. The buyers might be worse off collectively, but individually, I don't have an incentive to reduce my delta. That's the key trade-off. If you compare that to,
yeah, sure. Yeah, so you have many buyers, right? So here it's more like so other buyers take so one buyer take other buyer's delta choice as a given. So it's kind of notation-wise. So each buyer chooses their own delta, and the equilibrium is kind of symmetric. So all the deltas are identical.
Correct. That's exactly right. Yeah.
Okay. Yeah.
That's exactly right. And now it's going to be look if you look at the planner's prime. So the planner's prime is what? Well, it's maximizing. So this is the welfare of one buyer. The planner is maximizing the welfare of all the buyers, so n bar times the welfare. The welfare function is the same, it's VB minus big lambda. So what's the difference? Well, the difference is that the planner understands that VB is a function of delta and market tightness. But market tightness itself is also a function of the average delta. This n of delta here, the second derivative, the second component in the value function, does not appear here because from the perspective of one buyer, I take n as given. So I don't take the derivative of n with respect to delta. Okay, the planner does. So obviously what happens is if you look at the planner, the first two terms here. These are the private marginal benefits and marginal cost. So this is exactly the part that each individual consumer would do. So the planner would do the same here. But then the second term here, it involves N prime. Okay, that's the effect what the planner takes into account, the impact of delta on market tightness. That's the new term. Now that term could be positive or negative depending on where you are. Okay, so if N prime is negative, then the planner wants to reduce delta. Okay, if this guy is negative, okay, then that lowers welfare. So if market tightness decreases with delta, then the planner wants to reduce information disclosure. Okay, so when is that likely to happen? When delta is high, either because the match efficiency is large or because delta per bar is large. If it's the opposite, if N prime is positive, the planner wants to encourage disclosure. This is true when delta is small, which is either the alpha bar is small or delta bar is small. Okay, so I think that answers the question we had at the beginning. What's the difference between traditional platform and the new internet platform? Well, I don't think there is a fundamental difference in terms of economics. Like these are quite similar if you think about the big picture. Like this is a place where buyers and sellers meet, so it's a matching function together with a system to gather information. It's more like the qualitative difference comes from the fact that the quantitative difference exists. So I would argue that the new internet platform, they have a much higher value of alpha bar and delta bar. Therefore, they are much more likely to be in the range of parameters where there could be excessive disclosure. The traditional retail platform with relatively low alpha and delta, they were probably in the region where disclosure was good, even from a welfare perspective. Okay, so what happens here is that the whether there is excess or disclosure or not, that's a inverse U-shape function. Okay, it depends on where you are. Okay. And if you think that the new platforms have higher efficiency of matching and information processing, then the proposition is that they are more likely to be in a state space where there is too much disclosure. Okay, so that's one example of what this happens. So remember, the key is market tightness and seller's entry. Okay, so here this is the function of delta. So this is a model where you can think of it as delta is delta bar. Okay, so, and I think it's a model with two goods. So the minimum is 1/2. Okay, so between 1/2 and 1. So this is market tightness. So it always decreases with delta. The number of buyers on the platform goes up with delta. Okay, so that's the gatekeeper effect. If delta is better, more and more buyers go to the platform. Okay, so that goes up. This is the effect on the number of sellers entering. Okay. Initially, it's going up. Okay, so start from delta is not too high. An improvement in delta will increase the number of sellers. Why? Because of the market efficiency effect, because of the matching effect. But when delta gets too high, the number of sellers starts to go down. That's the market power effect kicking in. So if you look at welfare, the optimum for welfare is around here, that delta star. That's the disclosure that the planner would choose, maximizing welfare. And then the one chosen by the buyer would be to the right of that. Now, how far to the right? That depends on the upper bound delta bar and on the shape of their private cost. Okay, but the generic proposition is going to be that it's above a delta star. Okay. All right. So let me just mention a few, I think, two extensions that I think are important. The first one is writing the platform as a pure monopolist. So I think the Nash bargaining is very transparent, so I think it's simple. But you could make the case that it's too simple. Also, in the Nash bargaining, the platform bargains with one seller at a time, which maybe you think it's not realistic. So we also solved the case of the pure monopolist. So it's like a platform, and the platform makes a take it or leave it offer to all the sellers. Say, this is the price if you want to trade on the platform. Okay, and it optimizes with respect to that price, exactly like a pure monopolist would do. So in that case, the platform also takes into account the fact that if he wants to attract a lot of trade, it should not put M, which is too high. So you have some small changes, but the big picture is the same. And in particular, the key point that the outside option of the seller decreases with delta. Okay, so the key insight we had, it also works in the case of the platform as a monopolist. Another extension that we find interesting is when buyers are heterogeneous. Okay, and I think that's important probably empirically because like the data we have, again, at least in the US, but I think it was the same in China as well from the data I saw, is that the average buyer on the platform is a bit typically richer than the average buyer on the outside market. So you can extend the model to have a distribution of U. Okay, so some people have a high U, some people have a low U, and you ask where are they going to go? Well, if you have a very high U, then you're willing to pay a high price for good information. So in fact, in this model, what happens is the high U consumers go to the platform. And as delta goes up, that's become more and more true. The marginal type buying in the outside market decreases. And so that adds another layer to the bargaining power effect. So if you have a heterogeneous buyer, the effect we have that I've shown you, they are still there, but there's an extra one, an additional one coming from the heterogeneity across buyers that reinforces the main effect. Okay, so what's the conclusion? We think that, so we model two key features, which we think are important of platforms: matching function, data gathering. The key of the data is that individually, consumers have an incentive to share data because that's going to improve their own likelihood of trading and finding the right product. So individually, I want to share as much data as possible. Now, you could add limit based on your own concern for privacy, okay? And maybe you don't go all the way to the maximum. But the key feature still is that you, as an individual consumer, will want to share a lot of information because it increases the likelihood that you can find the right product. What you don't take into account is that by doing so, you increase the gatekeeper effect. You make the platform the only place where consumers go, and therefore you increase the market power of the platform vis-a-vis the sellers, which means down the road that can reduce the number of sellers that go on the platform. And then as a consumer, that's bad for you because if there are fewer sellers, there's less competition among the sellers and you get a worse price. So that's the key fact. Okay, that is not internalized by the consumers. Whether or not there's too much or too little information, that depends on the parameter, which I think is a good feature of the model, because you don't want to have a model where there is mechanically too much or too little information. Okay, I think that shows you why this is not, that would not be the right model. In this model, it's ambiguous. There might be too little or too much information. But what we can say is that it's more likely to be excessive. There is more likely to be excessive data disclosure or data gathering when either matching efficiency or data processing efficiency is large, which is the feature that people associate with internet platform. So in that sense, even though Amazon is not that different from CVS in the sense that they gather data on their consumers and they have their own brand. So qualitatively, they are the strategies they are using are not that different from strategies that have been used in the past. The fact that they can do it at a higher scale, a higher level of efficiency, is the reason why you might want to limit their information. Okay, thank you very much.
Oh, thanks, Professor Philippon. It's very interesting. So we still have a few minutes left. Is there any questions for Professor Philippon?
It's late for you, no?
Yeah.
Yeah. So.
Oh, yes, I have questions.
Yeah.
Hi. So I have several questions. I think the claims, the copycat effect and the both effect you talk about seems to make sense in the kind of partial equilibrium in your setting. But I have several questions and suggestions. So I think you probably want to really to define what do you mean by platform. Now, what is a platform? Yeah, what is a platform? Because the platforms, they vary dramatically. For example, Amazon is the so-called platform, but in China standards, it's like if you look at Taobao.com, it's just extremely difficult because Taobao doesn't sell a penny of its own stuff, but Amazon has to sell a lot of its own stuff. Plus,
you mean like own brand?
Yeah, no, it's not only own brand. You see, it controls the whole. It actually blocks the buyer and seller side. It has a lot of stuff. It decides the price. It decides the stuff. So it's in a sense, it's quite a large chunk of that is like the Walmart. But then it also has the third party, the buy and sell. My point here is that this kind of hybrid, the combination varies a lot in different so-called platforms. And the issue we are talking about
well, I'm not sure actually. So it depends. So first of all, Amazon, as it turns out, they're selling their own brands is epsilon of their profits. So it's extremely small. In fact, as a fraction of revenues, own brands are higher at CVS and Costco than at Amazon. Where Amazon makes a lot of money is on selling advertisement. And it does control advertisement, that's for sure. And I think, well, and the fact that it's, yeah, but I agree with you that it could be different, but the model can account for that. Like depending on the parameters, the fees that the platform can charge will depend on the market structure.
But my point is that you're talking about platforms, but people will be confused by what you are talking about, because different platforms are different by nature. So some platforms, they actually separate buy and sell. So they have their own brands, this or that. So as you mentioned, some of that, but some of them it's really more by having get revenue from, let's say, the advertisement. And so it doesn't sell its own products. So that is different.
Yeah, but my point is that this is actually all the platforms. I think for all the platforms, the vast majority of their money is advertising money, and it comes from third-party sellers. The differences in the own brand is actually smaller than what people think. It gets people attention because sometimes it's a bit shocking. Oh, they're copying the successful small sellers.
But the own brand is the
fact,
stuff you're worried about, right?
No. That's actually I think it's actually small. We put it in the paper because it's important, because people discuss it in the antitrust. But I think the gatekeeper effect is much more important in practice, and that's entirely through advertising revenues.
So anyway, so my point here is that there are different types of platforms, and I think your and they have different combinations of how much they are just really intermediary. They're trying to match the buy and sells. For some of them, they copycat, they're doing things, and so they vary differently. So I think you want to probably have a clearer discussion of that. So to define your relevance of your insight.
But I want to push back on that, because I think that the copycat effect is more like if you think about ride sharing or Airbnb versus retail. So, as of now, still the case that the ride sharing don't actually own any cabs, so they don't compete with the sellers. Or if you think about or food delivery platforms, most of these guys, as of now, at least that might change in the future, but right now they don't actually own restaurants. So see, like a food delivery platform, it's possible. Why not? I mean, you could say a food delivery platform, they're going to see what people buy, the kind of taste, and then they're going to create their own little restaurants to sell the things. That could happen. Now, in equilibrium, we haven't seen that yet. So whether or not the copycat effect is there depends a little bit on the application. But again, my point is, I think the problem is in the news, people talk a lot about the copycat, but if you actually look at the numbers, like how much money, how much revenue that is, it's very, very small. So my sense is that for all of the platforms, the vastly dominant effect is the customer access and advertising. That's where they make their money. And I don't think that varies so much across platforms, actually. I think it's true for most of them. I don't think there's that much difference.
Well, you talk about a couple of things, and you're talking about the copycatting. So that's why I'm trying to. If you don't care about that, so
it's more like I think it's relevant in some contexts, maybe not, maybe less in other contexts. But I don't want to take away that the copycat is the entire story, because I don't even think it's the most quantitatively important effect. The key thing is just if you have a platform where everybody goes, I think that's then you can charge a high price for that, because people want to have access to your customers. The main difference, in my mind, between China and the US is there's more platform competition in China, because you have more than one.
That's
the main difference.
Thing.
But that's what Liang and you were saying earlier, which is what happens if you have platform entry. And then I completely agree. That's not in the model. That's the thing we want to do next.
But so that's even in this paper, because you are talking about platforms. And so for a casual reader, that thing is general application, but really you have a model here. And so for example, some of your prediction is about, so you are not thinking enough probably about the competition. So then if there's competition, because this is market-driven approach. So if you have competition, obviously, then they could move to another one. And another prediction, the prediction that the number of merchants could go down because of the externality you talk about. Have you verified that? Because a lot of the drive, as far as I know, for example, at Alibaba, they really want to get more merchants. It's crucial for them. It's like their goal. So they have a lot of incentive to keep those merchants.
I think I typically think that's exactly right. I mean, it's going to be a U shape or inverse U shape. Like, definitely early on, the platform wants to have as many buyers and sellers as possible, and then the question becomes: at some point, if they become dominant enough, they would have an incentive to start to change the terms of trade with their actual sellers. So most of what you hear if you read carefully the antitrust cases in the US. The vast majority of merchants who complain now about Amazon, they say 10 years ago it was great. But over the past 5 years, they've increased the fee they charge for advertising way more than we thought. And so that's exactly what happens in the model, which is initially, it all goes in the same direction. When initially an increase in alpha delta, everybody gets better off. But there's a point at which if the platform remains too dominant, then the next improvement is still gonna improve efficiency, but the increase in markup by the platform is so large that the merchant might be worse off.
So I think this is a much more insightful discussion than just looking at the abstract or just looking at the general message.
Yeah.
Because this is exactly the things I would appreciate that you can share the insight. You said, wow, this thing actually, they could have a lot of, because a lot of time, we have to ask a lot of time, when would business behavior become a kind of predatory behavior. It's like a monopoly stuff.
Yeah.
When is it a normal competition, a normal business behavior? But a lot of times you see companies, they use a lot of channels to collect information, helps them to change their product, do this or that. It happens a lot. I mean, it's very,
so
it's
in
only
our model,
at some time becomes an issue, right? So I think
so in our model,
really
the key statistics you want to keep track of is seller's entry. Now, of course, in the real world, measuring seller entry is tricky because, like, what does it mean? Is it number of sellers or the number of product that they offer? It's like but in theory, in the model, the statistic that allows you to track the welfare the welfare curve is the number of sales. In other words, the platform becomes too powerful when the number of sellers starts to go down. As long as it's going up, then the platform might be getting more powerful, but you haven't crossed the line where it goes down. So that's
So that's a great insight to put in so people understand, because we really at a point we can criticize platforms, but we really have at the point that we should provide them a reasonable critique. When are they good and when are they become a problem, right?
I agree.
Yeah. Then another thing is that I'm a little bit confused about. So you said this externality is not priced by the customer. Well, really, I don't think customers care about it, because customers benefit whatever product they like. And so let's say the thing. So I don't think it's on the sharing information part. So it's not really externality for the consumer, right? So because the consumers they get what they like. And even
but that's the definition of but that's because they take us. That's the definition of the externality, which is given the prices in the market and given the market tightness, for sure what you say is true. The problem is that when all the consumers change their behavior, then market tightness and prices adjust, and it's an externality via entry. So it's not technically the same as a pecuniary externality, but it's kind of related. It's like an entry externality.
Well,
maybe I'm not externality
on this, but my point here is that it's again related to the issue raised earlier by multiple people, is that if there's competition, then because on the consumer side it's not really a problem. I don't think it's like excessive data sharing or that, because that also relates to the issue of where does the value of the data sharing come from. But I think you mentioned correctly that because the sellers, they understand the merchants better, they provide better service, so they actually benefit from that. But this actually could have competition issues at certain point, but that's related to the free entry or for that part.
But I think that I agree. I mean, I think the key here, what the paper shows really is that if you want to understand. Even if you only care about consumer, like in the model, we only care about consumer welfare. But it turns out that consumer welfare depends critically on seller entry. So that's the key dynamics that you want to look at now.
Yeah. So that's great. So I think it's this is probably it's more I would appreciate. I think that the paper becomes more relevant to describe what's going on in this all kinds of different platforms. Is at what condition it becomes a problem, and what are the major empirical symbols, the features to describe this. And if you have some kind of support, that would be really wonderful. Otherwise, it's a little bit. I think the conclusion would be too general. We talk about gatekeeper. Which kind of gatekeeper? So that is the things I think, because we're talking about practical relevance, and I think it's. You have a very, very interesting insight, but it'd be nice to be more precise.
Okay,
that's all.
Any more questions for Professor Philippon?
Actually, I have two questions. Thank you, Professor Philippon. I enjoy your lecture, but as I entered into this session at a very later stage, so I missed the first part of your speech. Of this speech, the first question is that the critical thing in this model is that when the information gets more precise, you think that the increase in the price of information outweighs the benefits of additional matching efficiency. I'm wondering what are the preconditions for this to happen? And a second question is that what are the mechanisms for the information to get more precise? Can you specify some mechanisms for this? Because it's not necessarily the result of more data. We've heard of lots of research nowadays show that performance of algorithms stops improving with increasing volume of data at some point. So what are the mechanisms for this more information to get more precise? And will these mechanisms in some way have any influence on the result you are now drawing? Thank you.
Oh, yeah, Professor Philippon sent an email to me saying that his computer crashed. Great. Then I think maybe we can conclude here. So if there are any additional questions, we can communicate by email. Is that okay with everyone?
Yeah, it's okay with me. We can send our questions to him later.
Okay. So thanks everybody. I think we have to conclude here. Hope to see you soon in our future webinars.